Hi guys, and welcome to part 2 of a tutorial about getting bundled input functionality for ComputerCraft. At the moment it's 1.63 I'm using on here. As of making this video, you currently don't have that bundled input ability with ComputerCraft and these Rednet cables. If you just stumbled across this and you don't know what bundled input or output is or anything, what it basically means is in Rednet cable you have these colors that each cable can be, and what these do is, what the bundled input allows you to do is detect which colors are active. Now unfortunately we can't get like absolute perfect on this, is we do have to use up quite a lot of size of computer. So if you were trying to do this, you might have to, say for example, have a computer sending a wireless signal to something else, or any other sort of solution that allows you to send a signal to another computer. Okay, so the way bundled input works is it essentially treats these cables as a binary number. So if you're not comfortable with binary, you don't know what binary is, what you need to do, I'll just try and explain this really quickly. We'll just call it explain. Right. So if we think of, say, a base 10 number, if it's just got a single digit up here, so we'll just put X like that, that number can be 0, 1, 2, 3, oh, what have I done there? 3, 4, 5, 6, 7, 8, 9. So a single digit can have any of those numbers. But if we had, say, a second column, which would be something that had tens in it, so the second column would be, most left would be counted as tens, then we would have the same ability there, is we could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, any combination, so 1, 0 to 9. And then here we've got, okay, this is a 1, that's 11 to 19, 21 to 29, or 20 to 29, 30 to 39, 40 to 49, etc., etc. And if we wanted to go up to 100, we would need a third column again. Binary is exactly the same, except for it's base 2. So if we do the same thing here, well, this can be 0, 1, so 2 zeros and 2 1s. And what I'm going to do up here is show you what those numbers represent. So in this first column, it's quite simple. 0, 1 can be up to a value of 1. This column here can be a value of 2. And then if we were to do the same thing here, the next column to the left would be 4, and that could be 0 or 1. So in the same way that we do in in base 10, in that, the combination of these tells us what they are, it's the same in binary. So, even using this little table here, okay, the 3-digit number, if we wanted 2 plus 1, so we want to represent 3, we know that we need to have 1 plus 2, next one up would be 4, so okay, so 1 plus 2, so we need 0, 1, 1 in a 3-digit number. Same as if we wanted 5, well, we'd have to do a combination of the numbers we can use. So that would be 4 plus 1, so that would be 1, 0, 1. Or if we wanted 6, that would be 4 plus 2 plus 0. 4, 2, 0, sorry, 1, 1, 0. That's how binary works. And that's what this cable does, except for this cable here uses 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That is essentially the size of number we're using, and that can represent any number from 0 up to 65,535. But what we can do is we can split that into 4 smaller numbers, so 4 smaller binary numbers, represent that as a base 10 number, and then figure out what it would all be added together. So we can take the first chunk of numbers and say, okay, well, in And if we just, I'm just going to increase this table so you can see. We go 8. One moment. 0. And 1. So as you can see, that 4-digit number would be potentially 8 plus 4 plus 2 plus 1 would be 15. So we've got 4 numbers of 15. What we're going to do is split all those numbers up. So that's what we're going to do. So this one here would be 4 to 15, so 1 to 15. This one would actually represent the next 4 digits in binary, which is 16, 32, 64, and 128. But because we've cut it down to a smaller number, this is also 1 to 15, 1 to 15, and 1 to 15, or 0 to 15 for all of them. And then what we do is we just use this programmable Rednet controller to send that out into the ComputerCraft. And if you're getting the idea of how this might work, I'm just going to quickly go through this and then I will actually do a full explanation of how to do this. So if we take our first 4 colours on the cable, which is white, orange, purple and blue, whatever that colour is. What we do is, okay, so white's the smallest number, we apply a constant value of 1, 2 for orange, 4 for the purple, and 8 for the blue. Now what we've actually done here is we've used minimum gates. These minimum gates, what they do is they mean that this will, if you're just sending a signal directly into here, this will have a signal value of 15. What this minimum gate does is sends out the smallest number of 2 comparisons. So if this is 15, the constant we're applying it to 1, if it's active, it's going to send out a 1. Same on here for 2, 4, and 8. And this is also why we split it up into groups of 4, is because we will only ever have to represent the values of 1, 2, 4, and 8. So if we've got that full signal coming through, we will always get the numbers we want out of that. And then what we do is we just add those variables up and we output them to the left. And then we do it for the same chunk of the next numbers. So the lowest number is 1, 2, 4, 8. Add it all together, output it on the next colour to the left, and all the way through. Right. And then what we do in here is we basically add them all up. And I'm just going to quickly show you exit, edit, bundle, input. Now at this point you might be, if you're not used to program or anything, it might be a bit panicky. Now there should be a very easy way to do this. Should be a very, very easy way to do this. What we should be able to do is just take all those numbers, represent them as 1s and 0s, put them all together, and then convert that back to a base 10 number. Something we can easily do. Unfortunately, playing around with it myself, I found out that that functionality to turn things into 1s and 0s is currently not within the ComputerCraft that you download and use as a mod. And it goes through the Java at the moment. And I don't know if people would be comfortable using Java, whereas maybe just explaining some maths functions and doing the same thing over and over again might be easier. And the other side of it as well is converting 1s and 0s back to a number also seemed to be very finicky, and I felt like it'd be a lot easier to figure out what you're doing with something like this, where you can see very easily if you've done something wrong, or you might not necessarily be going into areas you're not comfortable with if you're just literally doing this for a fix, and you don't really want to use ComputerCraft for much else than that. Okay, so I'm going to get on with this tutorial now. So what I've got over here is I've arranged these ones how they would actually appear on a binary number. Those ones are actually back to front. Those are going from lowest to highest, whereas any number we use in every day always goes from highest down to lowest. And you know what, I am in danger of having bats turn up, and they really annoy me. There we go. Hopefully no one turned up. Okay, so what I've done here, as you can see, I've just set up the 16 colours, and I've filled this programmable Rednet controller with these logic expansion cards with 5 circuits on them. We won't even be using them all. And now what I'm going to do is just put a cable output to a computer. I'm using Advanced Computer, and I'm going to have 1, 2, 3. There we go. And I'm just going to change the numbers on these. What we'll do is we'll have it going in the order we're going to use it. So that's going to be the first set. Second set is going to be the second furthest right. Go back as a third. And the biggest number is going to be on the left with that number. Right, so first of all, let's get this program, shall we? I am just going to pause here for a moment because I hear a helicopter coming past and it's going to make a really loud racket. Apologies about that. Unfortunately, I do live in a massive city and we do get police helicopters going past sometimes. Or kellyhopters, I almost call them now. Right, so let's set these up. So the first thing we're going to have to do is represent these first four colours. So that's white, orange, this light purpley colour and this light blue colour, which is different to that other light blue colour and that dark blue colour. That's really confusing. So we're going to represent those first four colours as a 0 to 15 number. So we'll take our first colour here. It's coming in from the right. It's going to be the white. It's the first cable. We're going to give it a constant value of 1, and we're going to apply that to variable 1. And we're going to do is going to add another one of these minimum gates. Now, if you don't know what these minimum gates do, is they output, quite simply, the smallest number that you're comparing. So if we've got no signal on these cables, then the smallest number coming in from the actual cable, so on this one here, if we had no signal on here, the smallest number coming in would be 0 on this. That constant would be higher than 0, so variable 1 would be equal to 0. Now, this is going to get a little bit messed up if you're doing redstone dust to rednet back to this, but I can't really imagine you're going to be doing that. I imagine if you're using bundled input or output, you're going to have that redstone signal directly at the source. Okay, so the second one, constant 2, input from the right is a second colour, put that on variable 2. Once again, another minimum. This one will be equal to 4, so it would be the third digit on the from the right, so the third digit on the left, and it's coming in from the third colour. Put that on variable 3, and another minimum. This would be equivalent to the 8 column, and that's coming in on the 4th colour. Let's double check that's all okay. Yep. And that would be going out on the 4th variable. And now what we're going to do is add that up. So basically what these now do is, if the white's active, it's going to be a value of 1 in variable 1. The red's active, 2. So the orange is active, variable 2 in variable, value of 2 in variable 2. If that purpley mauvey colour is active, we're going to have a variable value of 4 in our third variable. And if the light blue colour is active, we're going to have a value of 8 held in variable 4. What we're going to do is add all that up. So we're going to do add up variables 1 and 2 and output that to variable 5, and we're going to output variable 3 and 4 to variable 6, and the final thing we're going to do is we're going to add up variable 5 and 6, so our two sums there. Fortunately, we don't have a bigger adding up thing here, I don't believe. And what we're going to do is we don't need to hold that in a variable. We're just going to output that to the left on the white. Now, we're now going to do that for the next set of numbers. So that's yellow is going to be our lowest. This dark grey is going to be our highest. And I won't waffle for this one. I will just get it done. You can watch it get done quickly. Okay, so as you can see there, I've set up, oh no, we want to output to the left. Second. So you can see now we've done our second chunk of numbers are now represented by that same 0 to 15 potential, and output on our second colour to the left. And now we just got to do that for the next two chunks of numbers. So the next chunk of numbers here is light grey to dark blue. So what we'll do is we'll do that again. Once again, I'll just let you see done quickly. And output them to the left on the third colour. So that will now be an analog redstone output. And now let's go to the final colours. Okay, so now we are outputting this to the left on the fourth colour. Okay. Now what we need to do is make the program that puts all this together, and no, it's night time again. Damn bats. Really annoy me. Okay, so what we're going to do is we're going to create ourselves a new program, whatever you want to call it. We'll call it B_I. Okay, so the first thing we're going to do is going to create ourselves 4 variables. We're going to call, just to make it easy, so local first, and we'll just do this local second, local third, and local fourth. Now what we need to do for each of these is we need to grab the analog input that we've just taken from the PCR and get these variables to hold it. Please excuse me a second, I'm going to kill those bats, they're annoying the crap out of me. Okay, let's go back into this. Do apologise about that, those bats are really annoying. Right, okay, so what we're going to do is we're going to grab the analog input that we've got there. So our first input we know is from the right. So we've got lowest numbers to the right, second lowest from the top, second highest from the back, and highest from the left. So we use the call redstone.get analog input right, and then we do the same for all of these. Okay, so the next thing we need to do is we're going to make a variable that we're going to hold the total in. It's going to be a running total, and basically what we're going to do is we're going to add up all the possible columns that these numbers represent. So we're just going to call this local. Local means it's a variable that's not used by other programs on the computer here. We'll just call this total, and we'll give it a lowercase because, to be perfectly honest, for some reason I always miss the capitalization on T. And we'll start off by saying this is 0. So if we don't have any other inputs, this is going to be 0. Right, so the next thing we need to do is we need to understand a couple of math functions we're going to do. I'm just going to save this. Right. So if we take our input from the right, which is going to be a value of 0 to 15, is basically representing this, is equal to 15. So if we want to get the biggest number of this, which so this is equal to the 8 column on there, what we need to do is divide that number by 8, and if that value that we get at division of 8 is 1 or greater, then we need to add 8 into our total. for the second number. On the 8 column, that would be equivalent to 128. So if we divide it by 8, so we divide our value from the top here by 8, so 1 to 15, divide it by 8, we get a 1, then a 1 or greater, then we add 128 to the total. For the third, in the same column, we add 248, and in the fourth one, we add in 32,768. So what we're going to do is a math function, because basically we're going to round it down. So we can divide it by the equivalent column, round it down, and take away what that column represents. So we do total equals total. Now you can do sort of plus equals and things like that in programming, but this will make it easier for you to understand exactly what's going on. Let's open up some brackets there, because it's going to be a little bit of a function here. Math.floor. So this whole bit here means you're rounding down whatever the answer is. First, so that's our variable up there, divided by 8. So this whole here, this thing here is going to be a value of 0 or 1. Because obviously 0 to 7 divided by 8 is going to give you a value, a fraction of less than 1. We round that down, it's going to be 0. Or if it's 8 to 15, it's going to be 1 to 1 point something, round it down to 1. And then we multiply that by 8. So there's 1 8 represented in this. And then what we need to do is take that away. So we do first equals first minus, and pretty much the same thing, math.floor, first divided by 8 times by 8. Now for the next one, we do total equals total plus math.floor first. So the next column would be the 4s times by 4 total, and then we take this away. Ah, really pain. Okay, sorry about that. And then we're going to take away the 4. Oops. Floor first divided by 4 times by 4. Now we're kind of duplicating what we're doing here. Still need to do it this way, but when it gets a little bit later on, you'll start maybe seeing it come into focus a little bit. So I'm just going to finish off these next two. So we do total equals total plus amount of 2's in there. Okay, and now we've only really got potentially 1 or 0 left inside that number. Even if it was 15, we would have taken away all other potentials. We could only have 1 or 0 left over. So we do total equals total plus first. On the later chunks that we're going to do, we're going to have to multiply the second, third and fourth. That last bit we could do, multiply it by a number. So what we're going to do now is put some comments in so we know where we're going. Now we'll just do calculation for 16 to 128. Right, won't do anything there. Right, so now what we're going to do is, we're probably going to have some errors in this. I'm sure I'll type things out wrong. So on that first number, the lowest possible numbers that we had is really we were only representing the numbers that were held in there, 0 to 15. What we could have done is just literally added whatever's in there, because that's what we wanted. But I wanted you to see this so you could understand exactly what was going on in there, because now you're going to see what's going on and the difference when we do the second number. So the first line for the second number is we do the same thing, math.floor. This time we're doing second divided by 8. So times by 128. Now that's different. And that's because what we're currently doing now is what we did on the first number is if we had our 16-digit binary number, we were adding the far right. So the far right was those 4, which could be a total of 15. But what we're doing now is we're adding in the next 4 numbers. So what we're starting off is this one. This is 128 here. We'll just split those up again so you can easily see. So this would be 128, 64, 32, and 16. So what we've got to do now is, okay, so if there is a value in that binary of 8, so it's divisible by 8, our sort of split up number there, then we need to add 128 to the total. And on the next one, if there's the value that represents the 64, we then need to add the 64 in, take away any potential of that confusing our next calculation, which is what we're doing here. It just means here, because if you divide something that could have 8 going into it, you're going to have 4. Whereas if you take 8 out of that number, if 8 was possible to go in and you take 8 out, well, 4 could only possibly go into any remainder, because there could only be 7 or less left in there. 4 could only possibly go in once, which is why we do it this way. So this represents 128, 64, 32, and 16. That's what we're doing here. And now, oh, there we go. That was very clever of me. Really? Bloody bat. Okay, second equals second minus math.floor. Second divided by 8. So we're rounding down division of second by 8. Now we just, once again, what we're editing here is not the total, we're editing second, the running total of second, so we times it by 8. So how many ever 8s you've got within that second 0 to 15 value to take it away. So if there's 0 8s, don't take anything away. If there's 1 8, take it away. And then we're going to do the same for the next value that this is representing. And we go all the way through here. Okay, and now in this finals number, well, we can only have 1 or 0 held in the actual second value, and that would be representative of 16. So we do total equals total plus second multiplied by 16. If there's a 0 in there, we're not going to get anything. If there's a 1 in there, we're going to get 16. And now I'm just going to quickly type out the rest of it. I'll speed this up so you can see what's going on. And at that point, we should have a working function. So let's deal with this. Okay, so we type that out. So as you can see, exactly the same thing as the second, the 8 column. If it's present, we add 248 to our bundled total. If the 4 column is present, we add 1024. If the third column, the 2 column is present, we add 512. And then the final total, we add our smallest number. Because it's going to be a 1 or a 0 in there, it's third multiplied by 256. There we go. Right, now let's do the final one. Okay, and now we're doing the very final one here, which is total equals total plus, oops, okay, well, let's get this not looking so funky, there we go, fourth times 4096. I'm going to have to go on a back killing spree again in a second. Okay, let's have a quick look over this, make sure there's nothing that I can see off the top of my head I got wrong here. Most likely going to have some errors at the end of this, but let's just double check. Okay, now what we're going to do is first of all kill that bat. Okay, now first of all I'm going to say whoever thought it was a good idea to, you know, have bats that spawn all the bloody time when you're doing creative, yeah. Okay, so what I'm going to do now is just quickly note down these colours here, and we'll call this one mauve and we'll call that one purple. So give me 1 second on that. Okay guys, sorry about that. I misplaced my notepad that I had me colour number corresponding on. Okay, so final thing we need to do is simply print total. And control to save, control to exit. Now let's do a quick check, see if we've got any errors come up. Okay, so line 4 attempt to call a nil. So edit B I. Wow. Fourth redstone got dot imper. Okay, there we go. Save and exit. Let's do that again. Okay. Redstone dot get analog input left. 4 1 2 3 4 fourth equals redstone dot get analog. Oh, good lord, I'm in Egypt. Okay, there we go. Now don't be panicking if you get that error of attempt to call a nil or attempt to divide by 0. All that means is if you set this up right, is you've just written something a little bit wrong. But we'll do an example here. So the first thing I'm going to do is I'm going to turn on the first one, and we should be getting 32,768. So let's do that again. There we go. Right, so what I'm going to do now is I'm going to do just a random test number that I just put 1s and 0s down earlier. So we're going to put down 2 on from that, 1, 2 more, another 2 more, 3 more, and those middle 2. So what we should be getting is 39,574. Yay! Right, and now what we're going to do is we're going to turn them all on, and we should be getting 65,535. That way we know it's just all adding up okay. There we go. So that is bundled input functionality. I hope this whole tutorial has been useful. I hope it gets around problems you're having if you haven't got the solution yourself already. Yeah, and give me any comments you need, any comments or any help you need or problems you're having in the comment section, or if you like the video or feedback, let us know about that. If you enjoyed the video, please do give us a like, think about subscribing. Hope you guys enjoyed it, have fun, and I hope you do cool stuff with this.